Alright guys, we are going to go ahead and get going here. So the first one I want to recap with you guys is 722. And again, we looked at this in class, but it's been over a week now. And so I just wanted to go over 4 or 5 examples with you guys, have you try a few before you get into the practice today. Because sometimes we just need a little bit of a brain refresh before we jump into some practice to kind of remind us what are the basic things we need to do for each of these problems. And what's kind of the way that we want to go through and solve them. So the first one we're going to look at here is when we're just dealing with a radical and some things underneath it, and we want to go ahead and simplify. Now remember guys, we do this by looking at our index and looking for a specific group size here. So I want to go ahead and break down my numbers and my variables so I can go ahead and look for my groups of 4 here to be able to simplify this. So remember, your index tells you your group size that you want. Okay, so for this first one, 729, I'm going to go ahead and break this down. And you can just use your phone calculator for this. You don't really need anything special or fancy if you don't have a scientific calculator. But 729, I'm going to go ahead and break that down into 3 times 243. Now, if you remember, it doesn't matter what you start with or even where you go from here. If you pick different numbers than me, that is okay. You want to have the same prime numbers as me as when we get to the end. 243, I'm going to go ahead and split up into 3 and 81. And remember, once you make a tree from something, we want to cross it off. 81, we can break up into 9 and 9. And then each of my 9s I can go ahead and break down into 3 times 3. So again, everything I made a tree from, I'm going to go ahead and cross those off. All right, my x's here, I have 6 of them. My y's, I have 3. And z's, we have 11. All right, again, we've got everything broken down. So now I want to look for my group size of 4. So looking at my 3s, I have 4 of them right here. I can't make any more groups. I only have 2 3s left. So these are going to be my leftover pieces. I have 4 x's. I can't make a group of 4 y's. And of my z's, I can make a group of 4 there. And a group of 4 there, and I don't have enough to make a group of 4 again. Remember guys, groups go with maybe on the top of your note sheet. Let's go ahead and write that. You can write groups go with. Hopefully you're writing this either on a line sheet of paper. I'm obviously just using blank sheet of paper. Whatever you have available to you is great to be able to have these few examples for before you get into practice. All right, so groups are going with me. So group of 3 all goes together on the outside with me. Same thing with my x's and my z's. Now I made 2 groups of them, so I'm going to put z squared on the outside. The squared accounts for both of these groups. Nothing else can go on the outside because I don't have any more groups. So now I need to look at my leftover pieces, and those are going to go back underneath my radical. Now this 3 times 3 is where I'm going to put underneath my radical as a 9. Remember, we multiply to put things back together. So again, 3 times 3 was left over. I put it underneath my radical as 9. I have x squared left over, y to the 3rd left over, and z to the 3rd left over. And this is our final answer. So again, from a radical, pay attention to your index, find your groups, groups go outside, leftover pieces all go underneath our radical. Let's go ahead and take a look at number 2 here. Now number 2 is a problem very similar to this, but it's set up differently. We're going to get to this eventually, but we've got to do a few things first. If you remember guys, when we are multiplying 2 terms together here, we need to add our exponents. Okay, we're going to add these exponents. Make that little note to yourself. So we've got 4/5 plus 7/5, and that is going to get me 11/5. That is now my new exponent. Base stays the same. So now we are going to be dealing with 2 to the 11 over 5. Okay, so base stayed the same, added our exponents. Hopefully you remember that rule, guys. I taught you guys power over index allows you to rewrite this in what's called a radical form. So power over index. So I'm going to be dealing with the 5th root of 2 to the 11th power. All right, now we're back to here. Now we can find our groups and rewrite this simplified. So let's go ahead. 5th root of 2 to the 11th. Oops, put one too many there. And the 11 twos underneath there. All right, I want to look for a group of 5. Right, group index, group of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have 2 groups of 5s. Remember, groups go with us. So this group of 2 will go on the outside. Same thing with this group of 2. And hopefully your brain is telling you that we want to multiply to put these together. And taking a look here, I have 1, 2 left over, so that is going to go back underneath my radical. To rewrite this fully simplified, 2 times 2 gets me 4, 5th root of 2. All right, so guys, just a few things at the beginning we had to add, but otherwise we're doing the exact same thing that we saw in this first example here. Let's go ahead and keep working. We've got 2 more examples down here. Go ahead and write these down on your sheet of paper. We're actually going to look at number 4 first. So looking at number 4, okay, in comparison to number 2 here we were multiplying, so we added our exponents. Now we're dividing, so hopefully your brain is telling you that we are going to subtract our exponents. All right, so we have 25 over 4 minus 10 over 4, and that is going to get us 15 over 4. So rewritten, this would be 4 to the 15 over 4 power. Okay, use our trick, power over index, to rewrite this in radical form. So 4 is my index. 4 to the 15th power. That's a lot of 4s. All right, let's expand this out and look for our groups of 4. Okay, looking for my groups of 4 now. So I've got 1, 2, 3, 4, 5, 10, 15 4s written out. And I'm going to go ahead and look for my groups of 4 here. All of those groups go with me. So 4 times another group of 4 times another group of 4, right? We made 1, 2, 3 groups of 4, so I brought all of those with me. And my leftover 4s, we can go ahead and put back underneath our radical. But here's the thing, hopefully your brain is remembering 4s are a little unique. We can actually make more trees here and probably find another group of 4. Looking at our last example here with 2, 2 is a prime number. We can't make any trees from 2, but we can do that with 4. So with 4, I'm going to go ahead and break this up. 2 times 2 for each of these. And taking a look, now I have another group of 4 that I'm going to bring with me on the outside. So these are now broken up. So 4 times 4 will get me 16, times 4 gets me 64. And now I'm also going to multiply that by this group of 2. I'm going to bring that group of 2 with me right there. And now I have the 4th root of this 4 left over, right? I can't make any more groups there. 2 times 2 got me back to 4. So fully simplified, guys, we get 64 times 2, which is 128, 4th root of 4. All right, we have 2 more examples to look at here as just refreshers of our brain. So let's go ahead and look at this one. Now we have exponents directly next to each other, so we are going to go ahead and multiply these exponents. So I have 2/3 times 5/2. And if you remember a multiplication, you multiply both across the top and across the bottom. So 2 times 5 gets me 10 over 3 times 2, which gets me 6. 10 over 6 can actually be reduced, which we want to do. We want to go ahead and divide this by 2 up top and on bottom, so that we can make life a little bit easier here. So 10 over 6 is going to reduce to 5 over 3. This is my new exponent. This is my new exponent. So now I can rewrite this as 3 to the 5 over 3. So multiply those exponents, 5 over 3 here. All right, I'm going to go ahead and rewrite this just like what we've been doing, power over index. So index, we're looking at the cube root of 3 to the 5th power. Reducing this fraction allows us to, instead of be taking the 6th root of 3 to the 10th power, now I only have 5 3s I got to write out. So it can make life a little bit easier for you. So cube root of 1, 2, 3, 4, 5 3s. I'm looking for a group of 3 of them, which will go with me on the outside. Move that up so you can see a little. And then I have the cube root left over of 3 times 3, which will get me 9. All right, guys, there is one last example I want to go with you guys before I let you get to practice time here, and it is as a reminder when we're dealing with negative exponents. So the last example I want to go with you guys is 2 to the negative 11 over 5. So this is the last example we're going to look at here, 2 to the negative 11 over 5. Now, if you remember right, guys, we just dealt with 2 to the 11 over 5 right here. And so I did this specifically for a reason. This is how we went through and solved it when we had a positive 11 over 5. Hopefully you're remembering when we have a negative, our rule that we need to do is to put under 1. Right? We need to make this a fraction. Okay, and so that's what we're going to do here. That actually changes it to a positive exponent. So everything we did from here, we are actually going to do from here, but we're just going to put it under 1. And so hopefully you're going to see the connection that when we have a negative exponent, we do all the exact same things as we've done before, we just put it under 1. So I'm going to go ahead and make this positive, and we're going to go 1 over 2 to the positive 11/5 now. And then we go through and we solve this just like what we've been doing. Power over index. So I get 1 over the 5th root of 2 to the 11th. Let's go ahead and expand this out and look for our groups of 5.